Linux is powerful, but mastering its file system and automation tools can take your skills to the next level. In this video, I will walk you through everything you need to efficiently manage files, directories in Linux. You will learn how Linux structures its file system and key directories, how to navigate, manage, and manipulate files using the command line, the differences between hard and symbolic links, and when to use them. Whether you are a beginner or looking to sharpen your skills, this guide will give you the tools to work smarter, not harder. Let's dive in. In Linux, all files are organized into a single unified structure, known as the file system hierarchy. This structure follows an inverted tree model, where the root of the system is at the top, and directories and subdirectories extend downward. The root directory serves as the starting point for all files and directories. The /root symbol not only represents the root, but also functions as a separator in file paths. For instance, if etc is a subdirectory within /root, it is referred to as /root etc. Likewise, a file named issue inside /root etc would be referenced as /etc/issue. Each subdirectory within /root is designated for a specific purpose, organizing system files efficiently. For example, /boot is responsible for the storing essential files required for booting the system. To better understand the organization of files, Linux classifies them into different types. Static files remain unchanged unless manually modified. Example, configuration files. Dynamic or variable files can be altered or updated by running processes. Example, log files. Persistent files retain their data even after a system reboot. Example, user configuration. Runtime files exist only while the system is running and are deleted upon reboot. Example, temporary process data. In this table, we have a list of some of the key directories and their rules in Linux system. /boot stores boot-related files required for system startup. /etc houses system-wide configuration files. /temp temporary storage files with automatic deletion policies. And /usr includes installed software, system binaries, and libraries. /var stores variable data like logs, databases, and website files. Starting with Red Hat Enterprise Linux 7, certain directories that were previously separate have been merged under /usr. These include /bin, now a symbolic link to /usr/bin, /sbin, now a symbolic link to /usr/sbin, /lib, now a symbolic link to /usr/lib, /lib64, now a symbolic link to /usr/lib64. These changes were implemented to simplify system structure and enhance compatibility with other Linux distributions. For further detail, consult the manual pages using man 7 and HIER. It's a short for hierarchy. A file or directory's path defines its location within the Linux file system. Paths are composed of directories separated by forward slashes. Since Linux organizes files in a hierarchical structure, directories can contain both files and subdirectories. File names in Linux can contain spaces, but since the shell interprets spaces as argument separators, special handling is required. If a file name or a directory name includes spaces, wrap it in quotation marks to prevent misinterpretation, for simplicity, and to avoid errors. It is generally recommended to avoid spaces in file names or directory names. An absolute path specifies a file's full location from the root directory /. Since each file has a unique absolute path, the system can directly locate it. Absolute paths always begin with /. For example, the system log file has an absolute path /var/log/messages. Absolute paths can be long to type, so relative paths provide a more convenient alternative in many cases. When a user logs in, their default working directory is their home directory. System processes also have default directories. The current working directory refers to the location from which commands are executed. Relative paths specify file locations based on the working directory. A relative path does not begin with /, but instead provides directions from the current directory. For example, from the /var directory, the log file can be accessed as log/messages. Linux file systems, example like ext4, xfs, btrfs, are case sensitive, meaning file case F capital and C capital, which called camel case, and file case all in small letters .txt are distinct files. However, some non-Linux file systems like vfat and ntfs are case preserving, but not case sensitive, meaning the two names would refer to the same file. Use the pwd command to print the current working directory. To list files in a directory, use ls. If no argument is specified, it lists the contents of the current directory. The cd command changes the current directory. Without arguments, it returns to the home directory. The default shell prompt displays the last component of the absolute path. If the home directory is the working directory, tilde is shown instead. The touch command updates a file's timestamp or creates an empty file. The ls command has options to display file details. -l shows detailed information. -a includes hidden files. -r lists subdirectory contents. The dot represents the current directory. The dot refers to the parent directory. Hidden files start with a dot and are excluded from normal ls output. Use ls space -a to view them. cd space - switches to the last used directory. cd space ... moves to the parent directory. System administrators frequently perform file and directory operations such as creation, copying, moving, and deletion. Some commands directly interact with files, while others manipulate directories when specific options are used. Understanding command options is crucial, as their functionality can vary across different commands. The mkdir command allows users to generate directories. It accepts a list of paths as arguments to create one or multiple directories at once. If a directory already exists or a required parent directory is missing, mkdir fails and outputs an error message. To avoid this, use the -p small flag to create any necessary parent directories. Be cautious when using -p, as mistyped directory names may create unintended folders without errors. The cp command duplicates files either within the same directory or into another specified location. To copy multiple files into a directory, specify the target directory as the final argument. By default, cp does not copy directories unless the -r for recursive flag is used. The mv command moves files between locations or renames them. First example, renaming a file. Second one, moving a file into a different directory. The third, adding -v provides verbose output for confirmation. The rm command deletes files. It doesn't remove directories unless the -r for recursive flag is applied. First example, to remove a file, and then to remove a directory and its contents. For safer deletion, use -i to prompt confirmation. The rmdir command can remove empty directories. However, non-empty directories require rm -r. In Linux, you can assign multiple file names to the same data. These alternate names, known as links, allow files to be accessed using different paths. There are two primary types of links. Hard links directly associate a file name with its data on disk. Symbolic links or soft links create a reference that points to another file name. Each method has its advantages and specific use cases. Hard links. When a file is created, it starts with one hard link, its original file name mapped to its data. Creating a hard link generates an additional name for the same data, making the two indistinguishable. To determine if a file has multiple hard links, use the ls-l command. The output includes a link count showing how many hard links reference the file. Here, the file new file has one hard link after creation. Use the ln command with two arguments. First, the path of the existing file. Second, the new name for the hard link. Now, both names refer to the same data. You can verify hard links with inodes. Use ls-i to display inode numbers. If two files share the same inode, they are hard links to the same data. Since both files share inode in this number 19054.087, they point to the same data. The key characteristics of hard links. All hard links to a file share permissions, ownership, timestamps, and content. Changes made to one hard link affect all others. The file's data remains accessible as long as at least one hard link exists, even if the original name is deleted. Here in this example, even after deleting new file.txt, the data is still accessible via the new file. The limitations of hard links: cannot link two directories for safety reasons. Only work within the same file system. To determine file system boundaries, use the command df. Here you can create a hard link between your home folder and /temp, but not between your hard or your home folder to /boot because it's on a different partition. Unlike hard links, symbolic links create a pointer to another file or directory, rather than directly linking to data. Advantages of symbolic links: can link across different file systems, can reference directories, not just files. To create a symbolic link, use ln-s with two arguments: the target file, the original one, and the symbolic link name. You can see here in this example, command ln-s the original file, new file -link2.txt, and the symbolic link name under /tmp. The L at the start of the listing indicates a symbolic link. If the original file is deleted, the symbolic link remains but becomes broken. Here in the example, we deleted the original file. When we run ls-l on the symbolic link name, it shows in red. If we tried to cat on the file, it gives us an error: no such file or directory. A broken symbolic link still exists, but points to a non-existent file. Key differences between hard and symbolic links: points to data. For hard link, yes. For symbolic link, no. Points to file name. Works across file systems. For hard link, no. For symbolic link, yes. Can link directories. For hard link, no. For symbolic link, yes. Remains valid if the original file is deleted. For hard link, yes, until all links are removed. For symbolic link, no, becomes broken. Symbolic links to directories act like the target directory itself. Here we created a symbolic link to /etc under our home folder with a different name, config files. The -p capital option in CD forces the system to resolve the actual directory path. Hard links create an additional name for a file's data. Symbolic links create a reference to another file or directory. Hard links must be on the same file system, while symbolic links can span across file systems. Deleting the original file breaks a symbolic link but doesn't affect hard links. For more details, refer to the man pages for ln and info-ln. When you enter a command in the bash shell, the system processes it through multiple expansion stages before execution. These expansions allow you to handle complex tasks with ease, enabling powerful automation techniques. The primary types of expansions in bash include brace expansion, generates multiple string variations. Tilde expansion resolves to a user's home directory path. Variable expansion replaces variable names with their stored values. Command substitution substitutes the output of a command into the command line. Path name expansion uses pattern matching to select multiple files dynamically. Path name expansion, historically referred to as globbing, is especially useful when managing multiple files simultaneously. Using specific meta characters, you can match file names based on patterns, streamlining, patch operations. Path name expansion transforms patterns containing special wildcard characters into a list of file names that match the specified criteria. Before executing a command, the shell replaces the pattern with the matching file names. If no match is found, the shell treats the pattern as a literal string. Check the following table for common wildcard patterns. Let's do some examples here. First, creating sample files, make dir glob and cd glob to change directory to the created directory. And let's create few files here by using the command touch. And to verify the creation, we run the command ls. First, using wildcards for file matching, like ls space a asterisk matches file starting with the a character. The second one, ls space asterisk a asterisk matches files containing a character. ls space open bracket ac close bracket and then asterisk matches files starting with A or C. ls space 4 question marks matches 4 character file names. Only the file names with 4 characters will be matched. Here ls space and 5 question marks matches 5 character file names. Brace expansion generates sequences or multiple string variations within curly brackets. Here in this example, echo space open curly bracket Sunday, Monday, Tuesday, and we close with a closing curly bracket .log. The output, as you can see, Sunday.log, Monday.log, and here echo file, open curly bracket, closing curly bracket, and inside it's a range 1.3. The shell will expand this to a range starting by 1 and ending by 3. So the result will be 1, 2, 3. And then it will be substituted by the creating. Instead of using the command echo here, you can use touch or make dir. And here in this example, echo space file and ab inside closing and opening curly brackets and then 1 and 2. As you can see the result, it will go the first item with the second group first item and second item. And the first group second item will go again with the first item in the second group and the second item in the second group. You can use brace expansion to create directories in one line, like here in this example. The tilde expands to a user's home directory. So if we use it here, echo tilde root, that sign will be expands to a user home directory. So if it is root, it will start with the slash and so on. If the user doesn't exist, The tilde remains unchanged. Variables store data for easy retrieval and modification. Assign and retrieve values like this: username equal operator, and then echo to print the value of the variable. For clarity, use curly braces. Variable names must be alphanumeric and cannot begin with a number. Command substitution replaces a command with its output, like here in this example, echo today as, and we put the command between opening and the closing circle brackets, and don't forget the $sign. Avoid using backticks command for substitution due to readability issues. To prevent unintended expansion, escape special characters, like here in this example, echo the value of, and then you use the backslash before the $sign. Single quotes prevent all expansion, while double quotes allow variable and command substitution but block path name expansion. Understanding shell expansions and pattern matching in Bash helps streamline file management and automate tasks efficiently. By leveraging these features, you can handle multiple files dynamically and execute complex operations with minimal effort. In this video, we explored essential Linux file management techniques, including navigating the file system, using absolute and relative paths to locate files, directory management, listing, moving, and organizing directories efficiently, file operations, creating, copying, moving, and deleting files using the command line, file linking, understanding hard and symbolic soft links and their benefits, pattern matching, leveraging Bash wildcards to work with multiple files at once. Mastering these commands will make you more efficient when working with Linux systems, whether you are managing personal files or administering a server. Next steps to be taken: practice file operations. Try these commands on your own Linux system. Explore advanced file permissions. Learn how ownership and access control work. Test file linking. Experiment with hard and symbolic links to understand their differences. Stay connected, like and subscribe for more Linux tutorials. Drop a comment if you have questions or want more topics covered. Share this video with others looking to improve their Linux skills. Thanks for watching the Linux Lighthouse, your guide to master Linux. See you in the next video.